my talk today will be will focus on the special conservation prioritization for biodiversity conservation in the face of sea level rise and land use change. And as you know that climate change is a global attention. Yeah, and when both academically and at the government level. So when the former Harvard president visited China, she talked with the Chinese leader, and their dialogue focused on climate change and the responsibility of the government and the university. Yeah, and she also delivered a speech at China's Tsinghua University, and the topic is university and the challenge of climate change. So you can see that it's global attention for both at the academic, both for the academic, for the university and the research institutions, but also for the government. So, and today for climate change, I will focus on sea level rise, because sea level rise is considered one of the most certain, immediate, widespread, and visible results of climate change. And for IPCC, that's the Intergovernmental Panel on Climate Change, they did estimation for sea level rise. So at the end of this century, by the end of this century, the sea level will rise, the range of sea level rise will be 0.4 to 0.6 meter. But the report also indicated that the worst case scenario could be 1 meter by the end of this century. But this could be higher if the ice sheet that below sea level collapse. So it could be worse than 1 meter. And it's not on, so sea level rise is not only prediction, but it happens right now. So this picture shows you the tidal flooding on the color of a dead boulevard and the Beauty Avenue in Miami Beach. So you can see that it really happens, and this also shows you the high tides in Key West, Florida. Okay, so this also shows you the flooding in San Francisco during a winter hurricane. Okay, so to deal with sea level rise, NOAA has developed a tool called Sea Level Rise Viewer. So by using this tool, we can see directly the impact of sea level rise and the corresponding areas that along the coastline that could be impacted by flooding caused by sea level rise. So if you have property along the coastline, so you can check with this tool to see how sea level rise is likely to impact your property. Okay, so as we know that Florida is a coastal state, yeah, facing the Gulf of Mexico and also the facing directly to the Atlantic Ocean. So here is a estimation, is a prediction we did by GIS. So we can see that if sea level rise 1 meter, 10% of the state land are likely to be inundated by the rising water, and this could also cause 20% of existing conservation lands lost. So we have so if we should have adaptation strategies. Otherwise, habitats, species, and the entire coastal ecosystem are likely to be lost. And besides that, besides sea level rise, land use change is another threat. Here is the table shows you the estimated population in Florida and California. So we can see that the coastal population in the coastal states are growing. This map shows you the predicted population allocation in 2060. So we can see that there are two major threats for coastal states or coastal areas in respect of ecological conservation. So one major threat is sea level rise. Another one is land use change. So we have like a combined impact. The challenges for the coastal habitat is that the salt marsh along the coastline are likely expected to move upslope with the rising seawater, but the existing and the future development is expected to limit their migration. So for the coastal ecosystem, it's like they are trapped between the Delaware and the Deep Blue Sea. The Delaware is the development, is urban development. So this map shows you the combined impact of sea level rise and the development and the development on coastal ecosystem. So you can see that under the combined impact of sea level rise and development, the coastal ecosystem is will be trapped between the two threats. Okay, so here comes the question, the research question. So to facilitate biodiversity adaptation to sea level rise, we need to identify areas where existing conservation lands, like here's the Everglades National Park. Okay, so existing conservation lands should be enlarged, or we should establish ecological corridors, or we have to establish new conservation lands, conservation areas. So create new conservation lands. So all of these questions are the most urgent research needs for sea level rise adaptation. And this information are also important for coastal managers. Okay, here's a study area that is in northeast Florida. So here is a descent study area because it contains the Guantanamo-Matanzas National Estuary Research Reserve. So that's a national research reserve, and you can see the location of the study area. It directly faces the Atlantic Ocean and also under the threat of urban development. So it's a very descent. It's a salient case study. Okay, so that's only one of here. This map shows you all the national research reserves in the United States. So it have 28 national research reserves in the United States. So our case study here locates in northeast Florida. Yeah. So the research can be transferred to other research reserves. Okay, here's the bird eye view, the aerial view of the study area, one part of the study area. So you can see that it's the study area faces directly to the Atlantic Ocean. So if sea level rise here, you can see it will have a huge impact on the study area. Okay. So here's the methods. So we have developed an integrated modeling that incorporates a geomorphological model. We call SLAM here. SLAM is SLAM, and a species habitat model and a conservation prioritization model. Okay, so and we have 3 sea level rise scenarios here: 0.5 meter, 1 meter, and 2.5 meter. Okay, so the 0.5 meter, why we choose 0.5 meter? Because it's in the range of IPCC report between 0.4 meter to 0.6 meter. And 1 meter is the IPCC's estimation for worst case scenario. And 2.5 meter is an extreme case scenario. And it's also the extreme case for modeling SLAM. Okay, and for development projection, for future development projection, we use development projection conducted by a professor at the University of Florida. So here is the process for the modeling framework. Okay, there's for SLAM, it's called sea level affecting marsh model. So what this model can do is simulates wetlands and shoreline changes due to sea level rise, and the outputs of this model can be used to create future land use data. And species habitat models is developed by director of the Center of Conservation Planning at the University of Florida, and also Florida Fish and the Wildlife Conservation Commission, and Florida Natural Areas Inventory. So they have developed these species models specifically for species in Florida. And these models are developed based on species ecological affinities, and they have been peer reviewed. The inputs for the model are land use data, soils data, hydrological data, etc. So, and the outputs of this model can be inputs for the nation. The nation is special conservation prioritization software developed at the University of Helsinki. So we can use species habitat for inputs as inputs for this software. Okay, so here's the results. So this map shows you the black bear, one of the species we selected. So black bear habitat change under sea level rise scenarios. The red color shows you how black bear habitat are going to change under different scenarios of sea level rise. And here, this map shows you shorebird. Shorebird is a shorebird habitat change under sea level rise scenarios. The red color shows you habitat loss, but the green color shows you habitat gain. So for shorebird, it can gain some habitat under sea level rise, but it's also highly likely to lose some habitat to sea level rise. Okay, here's a summary of habitat gain and loss from sea level rise for all focal species in the study area. Okay, this is a habitat gain or loss from land use change for all focal species. So we can see that all species are going to lose some habitat to future development, right? Yeah. Okay, so these are the combined habitat gain loss from sea level rise and land use change for all species. So under the combined threat, under the combined challenge, some species like American oystercatcher were likely to gain some habitat, but most likely most of the species are likely to lose habitat under the combined impact. Okay, here's the summary, the total number of species gaining or losing habitat. Okay, here's the nation result. Okay, here we can see the 3 maps here. So the first map shows you the current donation results. The red color shows you the most valuable areas for conservation in the study area. The middle map, the second map shows you the most important areas for conservation. The red color shows you most important ecological valuable areas, valuable areas in the study area under 1 meter sea level rise. And the third map shows you the most valuable conservation lands under 2.5 meters. So we can see that under sea level rise, the valuable conservation areas are likely to shift. You can see that the red color are shifting, right? Under different scenarios of sea level rise. Okay, so and so we did a combined analysis using GIS tools. So the dark green areas shows you conservation, shows you important conservation lands under all sea level rise scenarios. So this can be called low regrets for conservation, right? Because even IPCC can only give a range of sea level rise. We cannot predict exactly or very precisely for sea level rise in the future. So we can only have these sea level rise scenarios. But regardless of how sea level is going to rise in the future, we have these low regress areas that used for conservation. Okay, so and we have this. We did a assessment for current existing conservation lands. So we can see that some under 1 meter sea level rise, but some important, some valuable conservation lands will be outside of existing conservation lands. So this means that existing conservation lands cannot protect some of the most important species or biodiversity if sea level rise 1 meter. Okay, and so this map shows you the important conservation lands outside of existing conservation areas under different scenarios of sea level rise. Okay, so these areas are these maps are very important because it provides information for coastal managers for future land acquisition that can be acquired to dealing with future sea level rise. Okay, so and we also did a analysis for Florida ecological green waste network. So we did a combined analysis that we can see that some of the Florida ecological green waste network, we can see that I have to give you a little bit background of Florida ecological green waste network. So we call it FEGN, identifies opportunities to protect landscape important for conservation, the state's biodiversity and ecosystem, and serves as one of the foundation for ecological conservation in Florida. So we used our results to assess FEGN, and we found that most of the areas in FEGN are good for conservation, even under sea level rise, under 1 meter sea level rise. Okay, so and also we used our results to assess development scenarios, and we can see that there is a conflict. For some areas, there are conflict between conservation priorities and the future development. So we can see that under sea level rise, there will be conflict between conservation and the future development. So we have to take some action should be taken. So some conservation priorities that could be acquired for adaptation to sea level rise may be lost to future development. So we have to take some action. Okay, so here's a sea level rise situation in China and Southeast Asia. So we can see that the dark color shows you future impact of sea level rise on the coastal areas of China and also Southeast Asia. Okay, and here is the conclusion. Okay, so population growth, rapid urbanization, and biodiversity conservation and climate change. These are all some of the most difficult and enduring challenges facing in the world today. But as an art of survival, and I think urban planning, geodesign, or landscape architecture can play a key role in addressing these challenges. Okay, thank you very much. Yeah, that's all of my for my presentation today. So if you have any questions, please feel free to ask. Okay, thank you.